Hello everyone, welcome. Learn to solve numericals step by step in an easy way. Today, let's practice physics numericals of chapter Light of class 10. So, let's start. First question is, a rod of length f by 2 is placed along the axis of a concave mirror of focal length f. If the near end of the real image formed by the mirror just touches the far end of the rod, find its magnification. So, इस क्वेश्चन में एक कनकेव मिरर है दिया हुआ और उसके सामने एक रॉड जिसका लेंथ f/2 है वो रखा गया है और यहाँ एक कंडीशन दिया हुआ है कि जो रॉड है उसका फार एंड जो इमेज जो रियल और इन्वर्टेड फॉर्म होगा उसके नियर एंड को टच करता है. सो वी विल यूज दिस इंफॉर्मेशन एंड वी विल सॉल्व एंड फाइंड द वैल्यू ऑफ magnification. We have to find its magnification. So first of all, let's draw a concave mirror. Suppose this is a concave mirror. It is given in the question that the focal length of the concave mirror is f. Suppose this is a point that is focus and the length, this length it is given, the focal length it is given f. अब अगर हम लोग मान लेते हैं कि एक रॉड है ए बी जो इस कनकेव मिरर के सामने रखा हुआ है ए बी. इस क्वेश्चन में ये कंडीशन दिया है कि इस रॉड का जो इमेज फॉर्म होगा इस कनकेव मिरर के से वो रियल इमेज होगा एंड इट विल बी सच दैट द नियर एंड ऑफ द रियल इमेज touches the far end of the rod. So first of all let's find out which is the far end of the rod and which is the near end of the rod. अगर ए बी एक रॉड है जिसका लेंथ f/2 इस क्वेश्चन में दिया हुआ है f/2, तो इस रॉड ऑब्जेक्ट विच विल एक्ट एज एन ऑब्जेक्ट इसका नियर एंड होगा ये बी. नियर एंड मीन्स कि मिरर से जो नज़दीक है. फार एंड मीन्स विच इज़ far from the mirror. So इस given object rod का near end होगा near end of given rod AB is B and far end of rod AB is A. अब इस कनकेव मिरर की वजह से जो रियल इमेज बनेगा वो इन्वर्टेड बनेगा बिकॉज इट इज़ रियल इट विल बी इन्वर्टेड. सपोज दिस इज बी डैश ए डैश विच इज़ रियल इमेज फॉर्म्ड ऑफ दिस रॉड ए बी. अब इस क्वेश्चन के अनुसार इस रियल इमेज का जो नियर एंड है वो ए डैश है और वो टच कर रहा है इस ऑब्जेक्ट रॉड के फार एंड जो ए है उसको. अब हम लोग जानते हैं कि अगर किसी ऑब्जेक्ट का इमेज कनकेव मिरर के कारण अगर फॉर्म हो रहा है और वो उसी पॉइंट पे फॉर्म होता है इन्वर्टेड एंड एट द सेम पॉइंट, देन इट मीन्स इट इज़ दिस पॉइंट ए इज़ एट सेंटर ऑफ कर्वेचर. सो यहाँ से ये पता चलता है कि ए एंड ए डैश एंड पॉइंट्स जो है एंड पॉइंट्स ऑफ गिवन रॉड ए बी एंड बी डैश ए डैश जो इमेज रॉड है और ए बी जो ऑब्जेक्ट रॉड है, तो इनका जो एंड पॉइंट्स है ए एंड ए डैश वो कहाँ पर है? दे आर एट सेंटर ऑफ कर्वेचर क्योंकि वो लोग एक ही जगह पर फॉर्म हो रहे हैं. तो यहाँ से ये पता चलता है कि ये दूरी जो है ए एंड पॉइंट का दूरी इस पॉइंट पी से जो पोल ऑफ द मिरर है वो दूरी है जो सेंटर ऑफ कर्वेचर है. ए अगर सेंटर ऑफ कर्वेचर पे है तो ये दूरी होगा 2f के बराबर बिकॉज इट विल बी द रेडियस ऑफ कर्वेचर. सो ए पी इज इक्वल टू 2f, ए बी इज इक्वल टू f/2. इट इज़ गिवन इन द क्वेश्चन. सो वी कैन फाइंड आउट बी पी and this BP will represent object distance of this object rod AB from the pole P of the concave mirror, and this object distance we can represent it by U also. this we can find out by subtracting f by 2 from 2f. ये 2f है, पूरा दूरी 2f है, उसमें से ये f by 2 माइनस कर देंगे तो ये दूरी निकल जाएगा जो ऑब्जेक्ट डिस्टेंस होगा. सो 2f माइनस f by 2, after solving we will get 3f by 2. So object distance u इज इक्वल टू माइनस 3f बाई 2. यहाँ निगेटिव साइन का मतलब है कि ये डिस्टेंस जो है इट इज़ टू द लेफ्ट ऑफ द मिरर, इन फ्रंट ऑफ द मिरर, टू द लेफ्ट ऑफ द मिरर, एंड सो इट इज़ टेकन एज नेगेटिव. नाउ वी नो बाय मिरर फॉर्मूला we know 1 by f is equal to 1 by v plus 1 by u. यहाँ f जो है वो फोकल लेंथ है मिरर का, u is object distance and v is image distance. So we can use this formula and we can easily find out the image distance. F is focal length 1 by f, v we don't know, we have to find out, and u is equal to minus 3f by 2. So here we will write 2 by 3f. So 1 by v is equal to minus 1 by f plus 2 by 3f is equal to, which implies 1 by v is equal to minus 1 by 3f. So it means v, which is image distance, it is equal to minus 3f. So image distance is minus 3f and object distance is minus 3f by 2. Now we have to find out magnification. We know the formula of magnification. Magnification is equal to minus v by u. V is image distance, u is object distance. Now we will put the values. V is equal to minus 3f, u is equal to minus 3f by 2. So it will be equal to 2 minus 3f. So finally we will get that, and magnification is equal to minus 2. So this way we can find magnification. Actually in this question we have used this information which is given in the question, that the near end of the real image touches the far end of the rod. This information, with the help of this information, we can easily find out that the endpoints A and A dash lies at the center of curvature of the concave mirror, and so this distance is 2f, and with the help of this distance 2f, subtracting it from f by 2, we can find out the object distance, and using mirror formula we can easily find out the image distance, and then with the help of this formula magnification is equal to minus v by u, we can find out magnification, which is equal to minus 2. Now next question. An object 2 cm high is placed at a distance of 16 cm from a concave mirror which produces a real image 3 cm high. Find the position of the image, and second, what is the focal length of mirror. So in this question it is given that the height of object is, suppose if we represent it by h1, it is equal to 2 cm. Also height of real image, if we represent it by h2, it is equal to 3 cm. Now it will be negative because it is mentioned in the question that the image is real. So it will be inverted, and if it is inverted, we will write negative sign. Now we have to find the position of the image. First of all, we will, with the help of these two information, that is the height of the object and height of image, we can find out the magnification. We know magnification is equal to height of image by height of object. So here height of image is -3, height of object is 2. So -3 by 2, which is equal to -1.5. So magnification is equal to -1.5. Also we can use another formula of magnification, that is magnification is equal to -v by u. यहाँ पर v है इमेज डिस्टेंस एंड u है ऑब्जेक्ट डिस्टेंस. मैग्निफिकेशन हम लोग को पता है -1.5 है. we have to find out. u object distance, it is given in the question, it is equal to 16 centimeter, and as we know that the object is always in front of the mirror, so it will be taken negative. So solving this equation, we can find out the image distance, which is equal to -24 centimeter. So magnification is equal to -1.5 and image distance is equal to 24 centimeter, and this negative sign shows that the image is formed in front of the mirror, that is to the left of the mirror. Now we have to find out the focal length of mirror. Second part is to find out the focal length of the mirror. Now we know the object distance is -16 centimeter, which is given in the question. Image distance is -24 centimeter, so we can use mirror formula to find out the focal length. By mirror formula, we know 1 by f is equal to 1 by v plus 1 by u. Putting the values, 1 by -24 plus 1 by -16. If we will solve it, it will be equal to -5 by 48, which is equal to -9.6 centimeter. So the focal length is, now this one is equal to, this is focal length is equal to 48 by 5, and then it will be equal to -9.6 centimeter. So in this way we can find out the focal length of the mirror by using the mirror formula. Now next question. An object 5 centimeter high is placed at a distance of 10 centimeter from a convex mirror of radius of curvature 30 centimeter. Find the nature, position and size of the image. So in this question it is given that the object distance if we represent it by u, it is equal to -10 centimeter, as the object is in front of the mirror. Also radius of curvature of the convex mirror, यहाँ पर convex mirror के बारे में बात हो रहा है, उसका radius of curvature जो है वो इक्वल है 30 सेंटीमीटर के. Also one more information is given in the question about the height of the object. So height of object is 5 centimeter. We have to find the nature, position and size of the image formed. First of all, we know radius of curvature is given, so we can find out focal length of the convex mirror. Focal length is equal to radius of curvature divided 2. So it will be equal to 30 by 2 is equal to 15 centimeter. Also it is a convex mirror, so for convex mirror the focal length will be positive because the focus will be to the right of the mirror, or we can say behind the mirror. So focal length f will be equal to plus 15 centimeter. Now using mirror formula, we know by mirror formula 1 by f is equal to 1 by v plus 1 by u. Putting the values, 1 by 15, f is equal to 15 centimeter. 1 by v we have to find out image distance, plus 1 by u is equal to minus 10. So 1 by v is equal to 1 by 15 plus 1 by 10, and when we will solve it, it will be equal to 1 by 6, which implies v is equal to plus 6 centimeter. Again, image will be formed behind the mirror, so we will write this positive signs, and so we can say that the position of image will be 6 centimeter behind the mirror. Now next, one more thing, nature of image. As the image is formed behind the mirror, so the nature of image will be virtual and erect. Now next we have to find the magnification. With the help of magnification, we will find the height of image. We know the formula of magnification, m is equal to minus v by u. So v, image distance, is equal to 6 and u is equal to minus 10. Solving this, magnification will be equal to 0.6. Also, magnification is equal to height of image by height of object. So m is equal to 0.6. Height of image we have to find out, and height of object, it is given in the question. Height of object is 5 centimeter. So we will write that, and so finally height of image is equal to 5 into 0.6, that is equal to 3 centimeter. Again, the image is virtual and erect, so the height of image will be equal to plus 3 centimeter. This plus sign means it is an erect image. So finally, the position of image is 6 centimeter behind the mirror, nature of image is virtual and erect, and height of image is 3 centimeter. So that's all for today. Hope concepts are clear to all of you. Thank you.